this snake game, how to create a state machine, how to implement the logic to move this snake, how the food spawn algorithm will work, and how the collision detection algorithm will work in this snake games. First of all, let's talk about how the UI is drawn, and we include the libraries we required, which is Wire, Adafruit, GFX, and Adafruit SSD 1306.h, which is used for the OLED screen. We define the screen 128 by 64, and because we are not using any reset pin in this, so we put it -1, and then we instantiate the display with the screen width and screen height. And next we are going to use a placeholder for game variables. These are for drawing purposes for now. Max length is 50 and block size is 4, which is a size of one game block in pixels. So the next thing is score, which is for now we put constant 120 and high score 250, which is just for demo purpose for now. And then we are going to say that we have a game over, a boolean to false. That will make over game over screen not to be displayed. We can turn this to true whenever the game is over, so instantly the state machine will shift to the game over UI. Next thing is about the snake body placeholders, and we are using 3 segments to be drawn. The snake length is only a 3 at the beginning. We can increase it if you think the snake size is too small at the start. Next, we are using arrays logic for the snake X and Y placeholders, and we are implementing max length, which is obviously we put the max length is equal to 50. Then we are going to use a food placeholder at a dummy location. Then we use this draw bounds. These are the borders around the playable area, and we are just simply drawing a rectangle or at this location, which is 0 to 16, and then we put the screen width height -16, and then the color would be the white. And next thing is draw score. The display set text size, we put this to 1, and then we put the text color to white, and we simply display the current score and the high score like this. So this function is only to be draw the current score and the high score. Next, we drawing the snake. The snake drawing is simply a for loop to snake length, and whatever the snake length is, we are filling the rectangle by fetching the snake X and Y, and then we putting the block here, which is to fill a rectangle for each segment. Next is to draw food, which is simply a rectangle filled on the food X and Y location. Next thing is a game over UI. So the game over UI simply clear the display, and then it set the text size into 2, so the game over will be displayed in a bigger size. Then we putting a simple one size of text and displaying the score, and then we are displaying the high score at the second line. So that's how the game over screen is being displayed. In the setup, we are initializing over OLED, and then we are clearing the display, and then we are drawing the score, bounce, snake, food, and then we put them to display. And see a simple demo of this screen, how this UI is being rendered on the OLED screen. We will change this loop to a full snake game, and we will check this if statement. If game is over, we are drawing the game over screen, then we are taking a delay of 2 seconds to let the user read whatever put on a game over screen. Then we are simply resetting the game again, and we are simply returning to the main loop again. And the next thing we do, if the game is not over, which means the game is running, then we read the joystick. We created this another function to read the joystick, and then we move the snake and we put them to display as a clear display. Then we redraw over UI with the draw score, bounce, snake, and food, and then we put them to this display. So that is being displayed. Then we take another 80 millisecond delay to a faster response to the joystick. And if we go back to save the high score, we are simply putting the high score into the EEPROM to fetch them later. And then we are resetting the game by putting the snake length to give it back to the 3, and then we initialize the snake position, which is a better static position at X and Y respectively. Then we are putting a direct moving right direction. We put the direction to let the snake move to the right, which is a good starting point. And then we put the score is equal to 0 and game over is equal to false. And then we spawn the food using a simple randomized algorithm. If we look into the spawn food function, we are getting the maximum X we have, which is a width divided by block, and the maximum Y we can get, which is a screen height minus 16 divided by block. This is the maximum number of blocks in Y direction, which is a playable area. So we have to put the food, we have to spawn the food inside that playable area. Next thing, we are simply creating two random variables to get the points of X and Y. Then we fetch this X using a random function, and we put the 0 to the maximum X. So that's where we need to put the food on 0 to X multiplied by the block size, which is obviously how much rectangle we are in pixels we need, which is a 5 in our case. Then we are putting the Fy, which is 16 plus random dot max Y multiplied by block size. So that's how we are getting a random location of a food on X and a Y location. And we are doing this unless check self collision. So if this Fx and Fy is being drawn the snake, so we don't want this random numbers to be onto the snake, so we need a new numbers if that is colliding to the snake itself. So we don't have to put the food onto the snake, so we need a new location which is not colliding to the snake. That's why we're calling the check self collision function here. The next thing, we are simply doing the food X, updating the food X and food Y location with these temporary variables, and that's how we are spawning the food, and that's how our spawn food algorithm works. The next thing we are going to do is to explain this check self collision algorithm, which is simply int X and Y getting two locations, and using a for loop we are simply iterating over the snake X and Y array. So we are returning true if it falls onto them, otherwise we are returning a false. That's how simply we can use a check self collision algorithm, so to avoid the food to be spawned onto the snake. The snake movement algorithm is very core algorithm, so which you need to learn. We are using two variables, new X and new Y, and we are initially using the direction of the snake and multiplied by the block size, and we are incrementing the X location by that. Similarly, we are getting a new Y location by snake Y, the 0th index plus the direction of the Y, in which Y direction the snake is moving, multiplied by the block size. So that's how we are fetching a new X and Y locations for the snake, and we are wrapping this logic corrected to bounds for Y and X wrapping. how we do that, we simply if the new x is less than 0, we are using that new x by screen width minus block size, so that should not be less than 0. We are rewinding the x to reappear from the starting position, and if the new x is greater than screen width, which means the snake is gone too far on the screen, and so we need that to be reappear from a starting position. So that's how we are reappearing the snake if it goes out of the play area. So next thing is a y-axis wrapping. We are doing a similar thing by checking the new y. If it is less than 16, we are using that screen height minus a block size, and if it is greater than equal to screen height, we are starting it from a starting position which is 16. So that's how we are moving over snake. And finally, we are checking if it is doing a self collision. This new x and y pointing is colliding itself. It obviously means that game is over, and we need to save the high score and return by game over, and we don't need to follow this snake movement anymore. So the next thing, what we need to do, if it is not colliding itself, it means the game is still on. What we do, we are simply creating a for loop, which is a similar for a snake movement, a snake drawing. We need to draw the snake into a new location, so we update the snake x and y location, and if this is equal to the food location, this new x and new y, which is ahead of the snake, if it is equal to the food, it means it get the food. What we do, we increase if the snake is not equal to the max length of the snake, we are incrementing the snake, and as we are incrementing the score as well. And if the score is greater than high score, we are updating the high score as well. And because we already eaten the available food in the playable area, we need to spawn a new food. So that's why we called a spawn food function. The last thing which remain to explain is how we reading the joystick. We are simply reading using an analog read function. We are using A0 and A1 for X and Y respectively, and we are getting the X and Y from the analog read function, and we are checking the threshold value, which should be the center point, which is approximately 512. So that's how the threshold defines the sensitivity, how much the joystick need to be moved before we get that it is sending the direction to be changed. And if we get that, we need to update the new directions, but before we fetch the previous directions. And similarly, we check if it is less than 512 minus threshold, it means it is saying to move left, and we are updating the directions to be moving left, and similarly we do for the other way around. So that's how we are checking for the y-axis as well. And the joystick is simply checking the threshold value, and if it is greater or less, we update the y direction according to moving up and down respectively. So and the preventing 180-degree reversal, we only allow the change if the new direction is not the exact opposite of the current, which means if the snake is already going to the right, we cannot move it to the left. So it can only go to the if it is going to the right, it can only go to the other way around. So that's how we checking it not to produce it, and that's how we are reading our joystick. So that's all for today's tutorial, and that's how we create a snake game in Arduino Uno.